Building an app and want to do so more efficiently? Heard of Firebase but not quite sure why nor how to use it in an app? Want to see a full web application built with Firebase where you can follow along with real code and write code along with me? You've come to the right place. In this video series, I'll show you how to build an expense tracker web application using Firebase and React. For the first video, which you're watching right now, we'll build the MVP where a user will be able to log in, add an expense with a receipt image and other relevant information, and view all their entered expenses with the most recent one first. A user will also be able to edit and delete these expenses, and once we finish building it, I'll show you how to deploy it so all of your friends can use the app too. We'll be doing all of this using Firebase Authentication, storage, Firestore, and hosting. In the second video, we'll build optical character recognition, or OCR for short, where instead of needing to input each expenses information manually, the user can simply upload the image and the relevant receipt information will be automatically extracted for the user to confirm. This is useful for when a user has a lot of receipts to upload from a business trip or vacation, or maybe they were just feeling particularly spendy, and we'll accomplish this using Firebase functions and the Google Cloud Vision API. Once the OCR feature is done, we'll probably want to roll it out gradually to ensure our users are still having a good experience on the app. So in the third video, I'll show you how to use Firebase Remote Config and Google Analytics to do this. Finally, while our users are enjoying our app, we'll want to make sure that they aren't forgetting to confirm their receipts or input new ones. To do so, I'll go over Firebase Cloud Messaging in the final video to send notifications to users. I hope you're as excited as I am to be building this app while exploring a lot of Firebase's products, which in my clearly unbiased opinion, has been super helpful in creating apps in general because it significantly speeds up the app development process. Before we dive straight into building this groundbreaking expense tracker, let's talk about what Firebase is. Firebase is Google's app development platform, and it's based on Google Cloud Platform. It also integrates with several other Google tools, such as Analytics and Ads, and as it's built on Google infrastructure, it is designed to automatically scale. While we are going to focus on building a web app since that's what I know best, Firebase does support a lot of different client app platforms. There are client-side SDKs for web, of course, as well as Android, Java, and Kotlin, iOS, Swift on Objective-C, Flutter, C++, and Unity for game developers. There are a series of server-side SDKs as well to plug into your existing backends. At a high level, Firebase is a suite of almost 20 different products, and it's intended to help you through the lifecycle of developing apps, which typically goes something like this. When you're first starting out, well, you'll need to build the app, and the build products can help you do that. We'll cover a few of those in this video. After your app is built and deployed, you can monitor how it's performing using the Release and Monitor products. And once you start thinking about how to grow your app to attract more users, as well as to retain the users you already have, there's the Engage products. Firebase does have a large variety of products, which may seem overwhelming at first. But the good part is, you can pick and choose which ones you want to put into your app. That's what we're going to do here. To use any of them, you just have to install the Firebase SDK to whatever platform you're using to build the app. And most of these products entail just a few lines of code to get the feature up and running. I'll take you through many examples of this. Without further ado, let's start building our expense tracker app. You can get the starter code by git cloning the GitHub repo linked in the description. And actually, I'm just going to follow my own instructions and do it along with you. So I'm on the repo, and let's copy and paste the URL. I'll open a terminal to git clone it. Just as a note, most of the starter code is just UI components at this point. And throughout this video, I'm going to focus on adding functionality with Firebase, even though we are using React and Next as well. You should be familiar with componentry and React hooks, and if you're not, I suggest brushing up on those before following through with the code. If you don't plan on coding along, still feel free to watch the video because I'll introduce the relevance of each Firebase product in the context of our app and give a brief overview of the product before diving into coding. This will hopefully help you understand when and why to use these Firebase products in case you ever want to use them for your own projects. So first off, we'll want to do a npm install because package.json has a lot of needed packages. Next, we'll have to create a Firebase project. So we'll go to Firebase console, which is at console.firebase.google.com. This is where you're going to see all of the usage information for each product that you use. We'll need to create a new project, so let's click on Add Project. We can call it Expense Tracker and then continue. On this next page, we can choose whether to enable Google Analytics, also known as GA. It's automatically enabled here, and if you don't want to enable it for now, that's fine, but we'll be needing it for remote config and cloud messaging in later videos. Let's go ahead and click on Continue. We'll have to choose a GA account, and we can just use the default account for Firebase. Once we create this project, a new GA property will be created in the GA account and linked to your Firebase project. And this link will enable data flow between GA and Firebase. Let's create project. All right, so now our project is ready, so let's continue. We'll have to add a new app to this project, and since we're creating a web app, let's click on the web icon. We'll give the app a nickname, which is how we would differentiate between the web app and, say, an Android or iOS app for the same expense tracker project. But since we're not planning on creating any other apps other than this web one for now, it probably doesn't actually matter what we call it. Let's just call it expense tracker. We'll also want to set up Firebase hosting since we'll eventually want to deploy this project so our friends can see it and use it. We'll register the app, and in our project directory, we'll npm install Firebase. After that's done, we should see it in package.json. And yep, here it is. We'll return back to Firebase console and copy this Firebase config. And this convenient copy button over here will let us get the entire chunk at once. We'll want to stick that into our firebase.js file, which will hold all of the Firebase-related initialization parts just to organize the code a bit. Let's delete analytics for now, since we won't be using it here. So what is this code doing? Well, the configuration object is how the Firebase library knows how to talk to your Firebase project. This Firebase configuration object gets passed to initialize app, which is a function that returns a Firebase app instance. You might be thinking, can I just copy and paste the configuration I see on the screen for my own project? It seems like what Andrea did is a security vulnerability, showing all of her app details on the screen for everyone in the world who watches this video to copy. And can't an unnamed YouTube viewer just delete all her Firebase data or something else bad like that? That's a really good question. The Firebase configuration object is perfectly safe to include on the client side because Firebase resources are protected by security rules. We can also use app check to make sure all requests come from our app for even more security. We won't go over either of those in detail, not only because this video is already packed with information, but my fellow Firebasers who know a lot more about those have made deep dive videos that you can find in the description. Now that we've copied the configuration from the console to this file, let's go back to the console to finish where we left off. We can click Next, which will then tell us to install Firebase tools. Let's go back to our terminal to do that. All right, back to the console again. We can save deployment for later, since there's not actually much to deploy right now. Let's continue, although we won't be looking at the console during this next bit. Going back to the code, we have a landing page here in index.js, which is what the user will see when they go to the home page. If we run our app using npm run dev and go to localhost 3000, we can see the home page. There's not much to do here except to log in, so let's click on the login button. Why isn't clicking this button doing anything? Oh, I know, it's not implemented yet. So what should we do? Well, clearly we need to build some sort of logging in system, but that also sounds really complicated, and I'm personally not a security expert by any means, So there's bound to be some problems in that regard if I tried to build this out myself. Also, as a user of many apps, I don't really enjoy creating a new account for every single app I use because not only is it repetitive to set up an account with my first name, last name, email, birthday, the name of the street I grew up on, and all that jazz, I then also have to remember my password, which is really hard because my memory is not that great, and we're supposedly using different passwords for all the millions of accounts that we have. It'd be really nice to not need to create a new account just to use this app. So what should we do? What should we do indeed? Firebase Authentication to the rescue, of course. I know you saw that coming. Well, let's talk a bit about Firebase Authentication then. Authentication at a high level provides customer identity as a service, meaning it lets your users sign in to your app using a sign-in method that they already have. Then, you can securely save user data in the cloud and provide the same personalized experience across all of the user's devices. Authentication also is integrated into a rules system that lets you grant or deny access to resources in other Firebase products like Firestore and storage, and it's ready to use out of the box. Lastly, authentication provides some advanced functionalities like email verification and account linking. Let's take a look at how we'll implement authentication in our expense tracker app. Before we dive into coding, we'll have to set this up in Firebase console. Let's navigate to the console and go to authentication. We'll click on Get Started, and we'll have to choose how we want our users to log in. We could pick all of these, but I'll just choose email and password first. We'll enable it, and then click Save. Now that we have authentication initialized in Firebase console, let's see what we need to do in code. We'll open firebase.js and import the getAuth function from firebase/auth so that we can get a reference to the service by using getAuth. We're going to keep all of these references here just for organization purposes, so any other references for services we use later will also be here. Great! Now that we have that done, let's think about authentication more holistically for our app. Throughout the app's components, we'll probably want access to the authenticated user, which will be helpful for user management, what to show on various pages, and for redirecting routes properly. Since all parts of our app will need access to this auth user information, we'll be using React's Context API, which is a way to share values between components without having to explicitly pass props around from parent to child. First, we'll open auth.js, which is where we'll implement all aspects related to auth. Let's create a context object, authUserContext, to store the default value of information we want our components to access. We'll need the authenticated user, which we'll store in authUser, and initially it'll be null as we don't have an authenticated user yet. We'll also want to know whether Firebase is in the process of loading data or not. So we'll store that into isLoading and set that initially to true since we'll be fetching data upon opening the app. To enable components to consume the values from this authUser context, we'll create an authUser provider to return a provider for the context we just created, authUserContext.provider. The provider component takes a value prop, which will contain the data we want to make available to our component tree. We'll make a function, return the value we want. Let's call it useFirebaseAuth. Inside of this function, we want to always keep track of the auth user and isLoading so we can return those, and we'll use a state hook to achieve this. Auth user starts off as null, and we'll have the loading state start off as true. How is this information going to change? Firebase Authentication keeps track of the state, and it comes with a built-in function called onAuthStateChanged that enables us to listen for state changes, and the state will change whenever a user logs in or out. We'll want to listen for those state changes, and we'll do so using useEffect. The first argument to the function is the auth service, which we have from our firebase.js file. And the second argument is a callback function, which we'll name auth state changed. Calling onAuthStateChanged will start the listener, and anytime the state gets changed, we'll want to update authUser and isLoading accordingly. Since the state is changing, we'll set isLoading to true. If the auth state is null, then there's no user, and we want to reset authUser to null. We've also stopped loading information by that point, so we need to set isLoading to false. If we do have a user, then we'll extract the UID and email, which we need for our app, and set the authUser with that information. Now that we're done loading the information, we can set isLoading to false. OnAuthStateChanged returns the unsubscribe function for the observer, so when the component unmounts, we'll call unsubscribe to stop the listener. With all of this, we can return authUser and isLoading from this useFirebaseAuth function. We can also add a custom hook, useAuth, to access the current context value. This will be helpful for when we want to access authUser and isLoading. Now that we have this authUser provider, we'll want to wrap it around our application in app.js. This ensures that the children components will be able to access this user content. With auth implemented functionally, how are we going to show it on the UI? One convenient aspect of authentication is that it has Firebase UI, which is a pre-built UI library with register and login screens, and the UI can be customized too. We'll be using this because it's a lot faster than building these screens ourselves, and it also handles tricky parts of authentication, like the forgot password flow. To use this, we'll use styled Firebase Auth from the React Firebase UI library. So let's npm install that with npm install react-firebase UI. Once that's done, we'll see it in our package.json. Now to use it, we'll go to our homepage, index.js. To use Firebase UI, we'll have to give it some configuration, and we'll first decide on the sign-in flow, which can either be pop-up or redirect. Pop-up will open a pop-up, as the name suggests, and redirect will send the user to a redirected page to sign in. We'll just use pop-up for our case. Once the sign-in is successful, we'll want to redirect it to /dashboard, and let's save that in a constant variable since we'll use it later too. Lastly, we can give users different ways to log in. If we're feeling nice, we can enable users to log in with third-party providers like Google, Facebook, Twitter, GitHub, etc., so they don't have to create a new account with this app. Although we should probably enable logging in with email and password, just in case they want to create a new account or don't have an account on any of those other platforms. Once users sign in with one of these services, the user gets assigned a record within Firebase's system, and this record includes a unique user ID and a signed web token. This way, we have a consistent representation of our users, one that we can use against both Firebase's services and any custom servers we might want to build, no matter how they sign in. For our app, we'll enable users to log in using email and Google. Now that we have this, we can use styled Firebase Auth and pass this configuration into it along with Firebase Auth. We'll wrap this with a dialog, which will be open or closed based on some local state stored in login. This login state will initially be false, as we don't want the login pop-up to be open upon coming to this web page. And once we click the login button, we'll set the login to be true, which will then open the dialog with our login pop-up. Upon closing the dialog, we'll once again set login to false, which will then close the login pop-up. Let's see this in action. If you stopped your server earlier to npm install, we can start it again by doing npm run dev, and we can again open our web app on localhost 3000. We see our login page just like before, and now when we click on the login button, it'll actually open up this pop-up. Yay! But let's not celebrate too early. Let's make sure it actually works. If I type in an email here, it'll automatically have me register since I don't have an account yet. So I'll make an account and type in my first name, last name, and password. it'll take me to the dashboard, which is in dashboard.js. Let's go check what happened in the console. If we go to authentication, we'll see that this newly registered email appeared here. We can see that the provider being used is email, when the account was created, and the assigned user ID, which we can now use to uniquely identify this user. Now, let's see what happens if I click on this logout button here. You might have predicted already, but it's not implemented yet. Let's see what we should do. We have this navbar component with a logout button in navbar.js. Right now on the UI, it says insert user email here. How do we get the logged in user's email? Earlier, we wrote our handy dandy use auth hook to be able to get the auth user. So let's call that here and create a constant auth user from calling it. From there, we can get the email field. So let's replace insert user email here with authUser.email. If we go back to our web app, we can see that my email is displayed here. Great. Next, we'll want to put some functionality into the logout button, which we already saw isn't doing anything right now on the UI. We want to sign out, which is actually a function provided by Firebase Authentication. Well, we could call it here on this logout button. We'll also actually want to clean up our context when sign out is called. So we're going to go back to our use Firebase auth function in auth.js to add this. We'll create a function sign out, and when that gets called, we'll call the sign out function provided by Firebase Authentication. After that's successful, we need to reset auth user back to null since there's no longer a user, and also set the loading state back to false. We'll also return this as part of use Firebase auth. Just to clean up the code auth a bit, since the cleanup code is the same here as the cleanup for when there's no user for auth state changing above here, we'll just move these two lines to a function called clear and then call those instead. So now if we want to log out from the navbar, we'll just call the signout function from useAuth. So let's go back to navbar.js and get that function from useAuth, then use that function as the callback for onClick on the logout button. Okay, so now when we visit the page again and click on this logout button, it does indeed log out. And we know this because the email address next to the logout button disappears. Functionally, that's fine, we do get logged out. But thinking about our user experience, we probably want to bring the user back to the landing page, not this dashboard page that's supposed to show user-specific information. How do we do that? Let's take a look at dashboard.js. We'll want to check whether auth has finished loading and whether there's an auth user. If there's not, we need to redirect the user back to the landing page. Let's try again to access the dashboard page. We're still logged out, so the correct behavior is that we won't be able to access the dashboard and will be redirected to the landing page. And we see that it does do that. But there's that momentary flash, which isn't really great. To fix that, we'll show a spinner if there's no auth user. If we access the dashboard now, we get smoothly redirected to the landing page. Much better. Let's log in again to make sure we can still see the dashboard properly when we are logged in. And we can. Great. What happens when we navigate to the landing page as a logged in user? The right behavior is probably to be redirected to the dashboard, but that's not what happens right now. We'll basically write very similar code to what we just did, except in index.js this time. We'll use an effect hook to check whether user information is still loading, and if not, redirect the user if an auth user does exist, since that means the user is already logged in. Now when we try to navigate to the landing page after already being logged in, we get redirected to the dashboard. But we get that flash again. So to get rid of that, we'll put a spinner if auth is still loading, or it has finished loading and there's an auth user, to give the UI time to react. Let's try to access the landing page again. We see that we get brought to the dashboard, and there's no longer a flash of the landing page before being brought to the dashboard. Let's log out to see that we can still access the landing page when we're not logged in. And we can. Good. All right, so now we're pretty much done with auth, and we've gone through the auth flow, mostly using email and password. But if you remember in our code, we actually also enabled users to log in using Google. Let's try that this time. We'll click on this button here again, and we'll choose to sign in with Google. Seems like there's an error telling us we need to go enable Google sign-in. Let's follow what it says and go back to Firebase console and take a look at the sign-in method tab. We see here that we've only enabled email and password, so we need to add Google as well. We'll click on Add New Provider, choose Google, enable it, pick a project support email, and then click Save. Once that's done saving, we'll see Google as a provider here now. Let's go back to our app and try this again. We'll click on the button and then pick Sign in with Google again. I'll choose an email address, and after waiting for a bit, we get redirected to our dashboard just like before. Let's check the console again. Yep, here we see my email address with the Google provider. All right, so now we're truly done with auth. It seemed like a lot of code, but in reality, we were just calling a bunch of Firebase authentication functions and putting them into the context of React to make it play nicely together. We didn't even really have to build a logging and UI either. So fast. What should we do next? A user probably will want to add an expense after logging in. And there's this button here. What do you think will happen if we click on it? Historically so far, every button we click on for the first time doesn't do anything. But surprise! It actually opens a dialog for the user to input receipt information. Once we click Submit, we'll want to store this image somewhere. But where? There's cloud storage for Firebase, and essentially, it enables us to store and serve user-generated content like images, audio, and video. It's generally used for storing big blobs of data that we don't need to change often, and the amount of storage will scale automatically, meaning that storage space will increase as we add more content and decrease as we delete content. Cloud storage also has a global edge cache, which means that if I just pulled up a receipt to look at it, storage will store that in a nearby cache. So if I want to see the same receipt again 5 minutes later, I'll be able to get that receipt image quite quickly. We'll want to upload our receipt images into Firebase storage, but before we can do that in code, we'll first go to Firebase console to initialize storage. We'll navigate to storage and click on Get Started. We'll open a window showing the default security rules, and these security rules limit who can access the resources stored in storage. We'll want to choose Test Mode, which allows all reads and writes if the project was created within the past 30 days. We will need to create real security rules that limit access to each object to the correct user, but this is fine for our purposes now. We can go ahead and click Next here, which will then give us this page to pick the location for a cloud storage bucket. The default is usually fine, though you'll want to be more choosy if you're not based in the US. This will be the project's default Google Cloud Platform resource location, and it can't be changed once you pick it. We can go ahead and click Done, and it's going to create our storage bucket. In storage, we can basically organize our images in directories, and for our app, we're going to make folder names using user IDs. Inside each folder will be receipt images named by date. This way, our storage bucket is organized to some extent, and we won't have issues if two users submit a receipt at exactly the same second. This will also help us create our security rules in the future, because each person should only be able to read and write to their own directory. We have this link up here, which is the bucket URL. Let's copy that, and before we use it in our code, we'll have to initialize the storage service in the same way we initialized Firebase Authentication. Open firebase.js once again, and get the service using getStorage. Looking at our app again, we want to store the receipt image into storage every time we click the Submit button. All of the code for this dialog is in an expense dialog component, so let's open expense-dialog.js in our text editor to see what's going on. This looks like a ton of code, but what it's all really doing is just showing the UI for the fields and also saving state for the form fields we see here. With that, let's open storage.js, where we'll write a function to upload the image. Since we're going to use our bucket URL that we copied from the console quite often, we'll make a constant to store it. To write a function that uploads the image into such a directory, let's name it uploadImage. We'll pass the image data and the user ID as parameters whenever we call this function, so we can store the image into the appropriate bucket. The date will be formatted properly, and the bucket will be the bucket URL constant we just made earlier, along with the given user ID and the formatted date. To actually upload the image to storage, we'll create a reference, as the files in a cloud storage bucket are presented in a hierarchical structure, just like the file system on your local hard disk. We need to create a reference to a file in order to enable our app to gain access to it, which then can be used to upload, download, delete, and list files. A reference can be thought of as a pointer to a file in the cloud, and references are lightweight, so you can create as many as you need. They are also reusable for multiple operations. With that reference, we'll call uploadBytes and pass a reference along with the image. As a side note, there are a lot of other file types you can upload to storage, and there are different functions to upload those file types. Feel free to check the storage documentation for more information. After we upload the image to storage, we'll want to return the bucket, so the bucket can be used for putting into our database later. UploadBytes will throw an error if uploading bytes fails from the Firebase side. Great, now it's time to call it. We'll go back to our expense dialog file, and the button for submitting it is here. When it gets clicked, we'll give it a callback function called handleSubmit, where we'll handle storing the receipt image into storage. We'll write that function here, and instead of it, we'll try calling uploadImage with the image stored in the form field. We also need to pass in the user ID, so let's get the auth user from useAuth, then pass in authUser.uid. If calling uploadImage succeeds, we'll want to call props.onSuccess, which is a component prop. And if it fails, we'll cache the error and call props.onError. Lastly, regardless of what happens, we'll do some component cleanup before we close the dialog. Now that we have our code done, let's see it in action. We'll navigate to our dashboard page and click on the Add Expense button. Let's upload a receipt image, and once we do that, there's the name of the receipt here. We can then fill out the rest of this form with the location name, the address, the items we got as part of this expense, and how much it costs. Just as a side note, the MVP of this app is made for just US consumers, so we're going to show these amounts in USD with a $sign when users view their expenses. Let's submit this and go to Firebase console to see this image actually uploaded. We're on the storage page, and we see the user ID here as a folder. Once we click into it, we see this file here, and if we click on that, we can see some metadata and a direct link to the image. Yeah, great! Our upload to storage worked. Okie dokes. So now, once a user clicks on submit, the image will get uploaded to storage. We'll also have to store all of this expense information in the dialog to a database so we can retrieve it later. For that, we're going to use Cloud Firestore, which is a NoSQL database where we can store data like strings, numbers, and whatever our app requires. You might be wondering why we have to use storage and Firestore, since they both seem to be storing information. Well, storage is usually used to store big chunks of data like images, audio, and video, data that we're typically not going to change too often. Firestore, on the other hand, is used more for structured data that we might be changing often. So while our receipt images are stored in Firebase storage, the receipt information will be stored in Firestore. How is data structured in Firestore? Well, it's a document model database, which means that all of the data is stored in documents and collections. We can think of a document as something like a dictionary or a hash table, as it has a set of key value pairs, which we refer to as fields, And the values can be a number of different types, anything from strings to numbers to binary values to JSON-y objects called maps. So here we have the document containing the fields we saw on the previous slide. Each of these documents is stored in a collection. Documents cannot contain other documents, but they can point to collections that contain other documents, which can then point to subcollections, and so on. In our expense tracker, each document will contain information from one uploaded receipt. Each receipt document contains some values, basically all of the fields we had in our dialog, so the date, name of the location, address, items, and amount. We'll also include the user ID who submitted the receipt and the image bucket from storage. Before we write code to store our information into Firestore, we're going to have to initialize Firestore on Firebase console, just like we initialize storage and authentication. We'll go to Firebase console to navigate to Firestore, and clicking on Create Database will open a window showing the default security rules, and these security rules limit who can access the resources stored in storage. We'll want to choose test mode, just like for storage, which, as a reminder, allows all reads and writes if the project was created within the past 30 days. We can go ahead and click Next here, which will then give us this page to pick the location for our Cloud Firestore bucket. We see here that we can't actually pick a location because we already picked one for cloud storage, so our Firestore bucket location is going to be at the same location as our cloud storage bucket. After we enable it, we're ready to go. Let's go back to our code and try to implement this. First, we'll have to initialize the Firestore service in the same way we initialized authentication and storage. Open firebase.js once again and add the service using getFirestore. With that, let's open the firestore.js file where we'll write a function to add the receipt information to Firestore. Let's call it addReceipt, and it'll take in all of the expense information that we want to save into Firestore as parameters. So that'll basically be the user ID, date, location name, address, items, amount, and image bucket. Now that we have that, we'll call the addDoc function, which adds a document, and the first argument is the collection in which we want to add this document. We'll give it our database service, which is just added in firebase.js, and we want to add it to the receipts collection. Let's make that a constant at the top of the file since we're going to need it for other functions later. The second argument to addDoc is the data we want to store into Firestore, so this again will just be everything we passed in as arguments to our addReceipt function. As a side note, addDoc returns a promise. Now that we have a function to add a receipt to Firestore, let's call that when we click on the Submit button in our expense dialog file. We'll need to make a minor change to the existing code here. Because we want to store the image into Firestore, we're going to need to store the return value of upload image into a constant. All right, now we're ready to call addReceipt, and we'll pretty much just pass in all of the form field data along with the auth user ID and bucket. Since addReceipt returns a promise, we'll want to await it to make sure we don't try to close the dialog before it actually adds the receipt successfully. Let's try it. We'll click on our Add button here, add an image, and then fill out the fields again with the date, location name, location address, items, and amount, then click Submit. The right behavior is storage will have our image, and Firestore will have a new document with this information. Let's go check both out. In storage on the console, we see our user ID here. Inside is our image with the timestamp. Great. Now let's go check out Firestore. We see our receipts collection was created, and inside is a document with receipt information that we just added. Yay! Alrighty, so now we're able to add expense information, and we'll want to show that information for the logged in user. Let's go back to our firestore.js code and add a getReceipt function that takes the user ID for whom we're getting receipts. We'll grab a list of the receipts with the given user ID, and we want to order it by descending date, meaning the most recent receipt will be the first in the list. To do that, we're going to use the query function provided by Firestore. And the first argument will again be the collection with the Firestore service and the collection name, just like the @doc Firestore function. The other arguments for the query function will be our queries, and we can use where, which takes a field to filter on, a comparison operator, and a value. In our case, we want to get all of the receipts where the user ID equals the function's UID parameter. We can order the results by using order by, and the first parameter is the field we want to order by, and by default, it'll order using ascending order. Since we want descending order, we'll pass a second optional parameter, DESC. Now that we've built out our query, we'll use Firestore's getDocs function to get the documents that satisfy this query, which will return the results as a query snapshot. From there, we can use snapshot.docs, which is an array of all the query document snapshots in the query snapshot. We want to iterate through each query document snapshot to get the information we need for each doc. To do so, we'll get the data from the document snapshot and add the relevant information as an object into a list of all receipts that we'll return. We'll mostly return the information that we got back from Firestore, except for a few items. We'll have to change the date into a format we can pass around on the client side. So we'll get the date from the receipt and call toDate on it. We'll also want to keep around the document ID, which we can get from doing documentsnapshot.id. We also need the image URL for the receipt so that it can be directly displayed in our UI. In Firestore, we had decided to keep the image bucket since it's needed for the reference, but that doesn't actually provide the image. We have to get the download URL for the URL of the image. So let's go back to storage.js to write this function. We'll use storage's getDownloadURL function and pass in the reference like before with the storage service and the bucket parameter. Since the function we're creating in our file is called getDownloadURL, we'll rename storage's function to getStorageDownloadURL. We'll then go back to our getReceipts function in Firestore to get the URL for each receipt in our database. Alright, so when should we call this function? Well, we want to show it in the dashboard after a user logs in, so probably somewhere in there. Let's open dashboard.js again, and we'll first set up a state hook for receipts to show, and initially it'll just be an empty list. We'll then iterate through the list of receipts to show a receipt row for each receipt in our UI. To show the receipt upon login, we'll use an effect hook and run the effect whenever the auth user changes. The auth user is going to change when a user logs in or logs out. So we'll check if an auth user exists, because that means a user is logged in. We'll then get receipts of the auth user using the user ID, and we'll set receipts to the returned list of receipts. The code we saw earlier, where we map through the list of receipts to show a receipt row for each receipt, will now render for each receipt in the list. Alright, let's go back to our app and see if this works. When we refresh the page, it should show us the receipt we previously uploaded to Firestore. Seems like there's this big red error saying that the query requires an index. If we follow that link, we can create it. So let's go ahead and do that. As the pop-up dialog says, Cloud Firestore uses composite indices, which store a sorted mapping of all the documents in a collection based on an ordered list of fields to index. And Cloud Firestore uses these to support queries not already supported by single field indices. So we'll go ahead and create the index so we can query receipts with ascending UID and descending date. This usually takes some time to build. What should we do while we wait? Let me tell you a joke. Just kidding. I know you probably don't want to hear any face-palmy jokes, so we'll just kind of fast forward to when the query is actually done creating. We'll go back to Firebase console, refresh the page again, and this time, we do see the expense we had inputted earlier. Seems like we're halfway done now. All we have left is editing and deleting existing receipts now. When we click on the edit button in this row, the dialog shows the appropriate expense information. Once we click submit there, what should our code do? Well, we'll have to use storage and Firestore once again. When we edit a receipt and the user replaces the image, we're going to want to update the bucket with the image. Let's go back to storage.js and write a replace image function that takes the image and a bucket. We'll use upload bytes just like in our upload image function, and since the bucket already has an image, the existing one will just get replaced. As for Firestore, we'll want to update the document with the new data. Let's open firestore.js and write a function called updateReceipt. Just like addReceipt, we'll pass in all of the information we need to store into the database. We'll use setDoc this time, which will create a document if it doesn't exist, or overwrite a document if it does. We'll get a reference to the document using our Firestore service, and since we want a specific document this time, we'll give it the receipt collection as well as the document ID for the document of the receipt that we want to update. We'll then pass in our receipt information. Alrighty, so now we want to call both of these functions when we click the submit button after editing the dialog back in expense.dialog.js. We'll check whether the dialog was opened for editing, and we'll check whether the file name in the form field state is present. If it is, then that means the user uploaded a new image because otherwise file name would be an empty string. And we shall upload the image into storage by calling our replace image function that we just wrote. We'll pass in the file and the image bucket. Then, regardless of whether the image was changed, we'll call updateReceipt and pass in all of the fields. We'll also have to make a small implementation change here to make our snack bar give the right information. Alright, let's check out our app and see whether this works. We'll click on the edit button for this expense here, and let's upload a new image and change some of the values here. We'll click on the submit button, wait a bit, and then we get a snack bar saying it succeeded, but our values on the page didn't change. Let's check the console. If we go to storage, navigate to our ID, and look at the image, it seems to be the updated one. If we go to Firestore and find our document, we also do see that our changed values are here. I wonder what's wrong. Let's go back to our app and try refreshing the page. Oh wait, so our data did change. It just didn't update on the UI. Well, let's fix that. Let's go back to dashboard.js and see what happens when expense dialog emits on error or on success. Seems like it calls on result, which basically sets the snack bar message. If you remember from earlier up here, we set receipts every time the auth user changes. One way we could fix this is every time our receipt is successfully added or edited, we call getReceipts and set the receipts on our UI to be a fresh list of receipts. More conveniently, Firestore actually has a function that lets us listen to a document for any real-time changes. So instead of needing to call the setter and getter again, we can use onSnapshot. An initial call using the callback we provide will create a document snapshot immediately with the current contents of the single document. And each time the contents change, another call updates the document snapshot. To incorporate this, we're going to change our getReceipts code a bit in firestore.js. Instead of using getDocs, we're going to use onSnapshot and pass in receipts query. The rest of our function will more or less stay the same, except after it's done getting all of the receipts, we're going to want to set receipts to all receipts. We'll pass in set receipts and set is loading receipts, since this function is continuously listening to changes. OnSnapshot returns an unsubscribe function that can be called to cancel the snapshot listener, so let's return that. We'll also have to modify our dashboard code a bit, where we initially set the receipts upon a user logging in. Instead of getting receipts once and setting it just once here, we'll call getReceipts and pass in setReceipts and setIsLoadingReceipts to have a listener on the receipts collection. When the component unmounts, we'll want to unsubscribe, so we'll return that. So now, let's go back to our app and try again. We'll open this expense to edit again, and we'll pick another receipt and change some of these fields. Once we click submit, Ah! We still get the same snack bar, and we also see our expense update. Woohoo! Alright, so last item of business, deleting this receipt. We have this delete button, and when we click on it, there's a pop-up wanting us to confirm deletion. Clicking on delete right now doesn't do anything yet, but we'll implement it. When we delete a receipt, we need to delete it from Firestore, and just to be extra good, we'll also delete that image from storage so we don't have dead images that aren't being used stored in our precious storage space. Let's start with Firestore. So open firestore.js and we'll write a function, delete receipt. We'll pass in the receipt ID and call delete doc with the doc reference. And as a reminder, we'll pass in the Firestore service, collection name, which is receipt collection, and the ID of the doc. As the name suggests, delete doc deletes a document. Done with that, let's do storage now. So in storage.js, we'll write our delete image function. To delete a file, we'll use the delete object function from storage and pass in the reference again with the storage service and bucket, just like we did for basically all of our other storage functions we've written here. With those functions, we'll have to call it in dashboard.js too. Our delete button is down here, and when it gets clicked, we'll call a onDelete function, which we'll write right now. We'll call delete receipt and delete image, then do some cleanup after. Alright, last test. We'll go back to our app, click on this delete button, and then hit delete. We'll see that our receipt did get deleted here on the UI. Let's check storage on the console really quickly to make sure that image got deleted. Since we only had one image here and it just got deleted, our storage should basically be empty. Woohoo! Looks like we created a web app that enables users to track their expenses. After creating an account and logging in, our users can add, view, edit, and delete expenses. And we did all of this relatively quickly using Firebase Authentication, storage, and Firestore. I don't know about you, but since we've made this amazing app, I definitely want to share it with my friends. To accomplish that, let's deploy it to Firebase Hosting, which provides fast and secure hosting for web apps, static and dynamic content, and microservices. We're going to open the command line and type in Firebase init hosting, then Firebase deploy. This usually takes a while, but after it's done, we'll be able to view it on this URL that we're given here. Let's check that the functionality we built is all still there. We'll first click on this button and enter an email address that we know doesn't exist in our authentication system yet. The UI will take us to register ourselves, so let's enter our first name, last name, and password. Clicking on Login will take us to the dashboard, and let's add an expense. We'll upload an image, choose the date, type in the location name, address, items we bought for this expense, and the total amount. We'll click Submit, and we see the receipt has been submitted successfully, and we can see it here on the UI. Let's add another one just for fun. We'll upload a different image, and again, type in all of this information. Choosing the date again, location name, address, items, amount. Let's submit, and now we can see both of them here in descending chronological order, most recent one first. We'll edit the first one, replace the image, change some of the fields here, and click on Submit. We see that the expense information has changed, including the image. Yay! One last test. We'll click on the Delete button, confirm the deletion, and see that the expense went away. Let's check our storage and Firestore that they also hold the right information. We should only see the one expense that's left in Firestore, and we see that the image bucket there is this. And that's the one we should see in storage, nothing else. Let's go check. We'll hit the storage button here, and it looks like the bucket that should be there is there indeed. Let's go back to our app and log out now just to double check everything's fine. And it is. We can log in with our new account information and this time, we shouldn't be guided through the register page. And we're not. We get prompted for our password, and we can see our dashboard with all the information from before. So there we have it. Thanks for joining me on this long but fruitful journey of building out the functionality of logging in with Firebase Authentication, uploading and retrieving images using cloud storage, adding, reading, updating, and deleting expense information using Firestore, and finally, deploying our fantastic app to hosting. I hope this was helpful, and see you next time where we'll use Firebase Cloud Functions and Google Cloud Vision to implement automatic reading of receipt images so we don't have to manually input information ourselves for each receipt. In the meantime, happy app building and happy Firebasing.